Now that we know how to solve exponentials, we're going to look at how to solve equations that have logarithms in them. So let's just start off right away with an example. Log base 4 of x plus 3 is equal to 2. We've got to figure out how to get the x out of the logarithm, because right now it's trapped inside of the logarithm just like before it was trapped inside of an exponent. So we've got to think, what's the opposite of a logarithm? If you remember, exponentials and logarithms are opposites of each other. So when we were solving exponentials, we used logarithms. So when we use logarithms, we're going to use exponentials. So here's what's going to happen. If you remember, the inverse properties say that if we had a number here that matched the number here, then those two would cancel out. So what we're going to do is we're going to make both sides become powers of 4. So this is now 4 raised to the log base 4 of x plus 3 equals 4 squared. So the 4 here and here cancel out, so that just leaves us with x plus 3 on this side, and 4 squared is 16. Last step is to subtract 3 from both sides, and we have our answer. It's as simple as that. You simply make both sides powers of whatever number your log has the base of. So let's look at another example. Let's say log base 2 of x minus 4 is equal to 3. Okay, this time our base is 2, right here. So we're going to make both sides powers of 2. So this 2 and this 2 cancel each other out, and it leaves just x minus 4. Over here we have 2 cubed, which is 8. Just add 4 to both sides, and you get 12. Simple as that. Alright, now we got those down pat. Let's look at one that's a little more difficult. Let's do log of x plus log of x minus 3 equals 1. So remember those properties we learned? They're about to come in handy again. Okay, we can't use an exponent right now. We can't make both sides exponents and it cancel anything out because we have two different logs being added together. So just like last time we needed to get the exponential or the base by itself, this time we need to get just a single log by itself. So what we need to do is combine them using the properties. Well, if you remember, addition can be changed to multiplication inside of a single logarithm. Okay, now we have to think, what's our base? Well, wait a minute, there's no base written there. So you got to remember, this is the common log. This is the one that's understood to have a base of 10. So we want to raise both sides to become powers of 10. So this 10 and this 10 cancel each other out, and it just leaves x times x minus 3. Over here we get 10 to the first, which is just 10. Alright, let's go ahead and distribute this over here. X times x is x squared. X times negative 3 is negative 3x. And I've told you before, anytime you see an x squared and an x, you're going to need to factor. So what you actually need to do is subtract the 10 from both sides. I'm going to start out over here and get x squared minus 3x minus 10 is equal to 0. Then our next step is going to be to factor. So we get x minus 5x plus 2 equals 0. Set both of those equal to 0 and solve. This one will give us x equals positive 5. This one will give us x equals negative 2. But remember, with logarithms, we're going to have to check and see if this will work. Okay, so you need to ultimately check both logs that were back in our original. But we'll just check the first one to start with. So here's what I'm doing. I'm taking these two numbers, 5 and negative 2, and I'm going to plug them in right here and make sure they work. Because remember, you can only take the log of positive numbers. So hopefully you can already tell where this is going. If I plug in 5, that shouldn't cause any problems. I can take the log of 5. But if I plug in -2, that is going to be a problem. I cannot do the log of a negative number. So we have to throw this number out, and our final answer will just be x equals 5. Alright, let's try one more like that, so hopefully that'll help cement it for you. We'll do log base 2 of x plus log base 2 of x minus 7. And all that's going to be equal to 3. So before, well, we know we want to raise both sides to be powers of 2 because the base is 2. But we can't do that when there's two different logs like that. We've got to combine them into one single log. So again, addition can be changed to multiplication. So we get log base 2 of x times x minus 7. Now we're able to raise both sides to be powers of 2. And we get x times x minus 7 is equal to 2 cubed, which is 8. Same process as the one I just did. Go ahead and distribute the x. X squared minus 7x equals 8. Subtract 8 from both sides. That gives me x squared minus 7x minus 8 equals 0. That will factor to be x minus 8 times x plus 1 equals 0. So set each of those equal to 0. Because if either one is 0, the whole thing is 0. And you get x equals 8 and x equals -1. But again, you've got to check your answer. I'm going to take the 8 and the -1, and I'm going to check them back up in here. Well, 8 works just fine. I can do log of 8, but I can't do log of -1, so I have to throw it out. Just one word of warning. If both of them work in the first one, you need to go ahead and check the second one also. Make sure it works in both of them. But if it doesn't work in the first one, it's not going to work, period, because it has to work in both. So for that matter, if you plug 8 in right here, that's also okay, because 8 minus 7 is 1. That's positive, that's no problem. So our final answer is just x equals 8. Okay, next we're going to do one with the natural log in it. And we're going to do 3 times the natural log of 2x equals 12. 3 times the natural log of 2x equals 12. Divide 3 by both sides, because you want to get that log by itself. And then this is the part where we normally raise both sides to the power of whatever our base is. Well, there's no base written here. So you have to remember, what is the base for natural log? It's e. So we make both sides powers of e, and we get e to the 4th. E to the natural log cancels out, and we end up with this. I'm going to leave it as e to the 4th for now. You can plug that in your calculator, but I know I don't want to round anyway until I get to the very end, so I'm just going to leave it written e to the 4th. My last step is to divide both sides by 2. So just in your calculator, plug in e to the 4th, and then divide that answer by 2. You get 27.30 when you round to 2 decimal places. Okay, so that's one with a natural log. Now I already have one written I want to look at with you next. It also has a natural log in it. It says n equals 461.87 plus 299.4 natural log of x. And this models the thousands of workers in, so notice we're going to plug in for thousands of workers, in the environmental industry x years after 1997. So n is the number of workers in thousands, x is the number of years after 1997. And the question asks, when will there be 1.5 million workers? Alright, so first of all, 1.5 million translates to 1,500,000. So I would put 1,500 in for n, because it's that many thousand. Then I have 461.87 plus 299.41 natural log of x. And I'm trying to solve for that x, to find out how many years after 1997 this will take place. So first I need to subtract 461.87 from both sides. Let's see what that gives us. 1500 minus 461.87 gives us 1038.13. That's equal to 299.41 natural log of x. Then we need to divide both sides by 299.41. See what that gives us. 3.467. Remember, leave the real one in your calculator so you can use it. Because the last thing we want to do is get rid of that natural log so we can solve for x. We do that by making both sides powers of e. So my last step is to do e raised to the number I just found in my calculator. So I'm going to do e and then do second answer so it uses the exact number for me. And I get 32.05. Now keep in mind, we haven't actually answered their question, because their question was in what year there would be this many workers. Well, keep in mind, x was the number of years after 1997. So we need to add 1997 plus 32 to find out that it should be in the year 2029 that we would have that many workers in the environmental industry.